Okay, I know you're thinking, wait a second. This does not look like Mr. Snyder's teaching setup. It's because it's not. Mr. Mitter's not here today. So guess what? I decided I'd come in and use his cool light board to do this lesson. So that's what we're going to do. So hopefully you'll enjoy this little change of pace today, and we're going to go ahead and do it this way. So hopefully you guys are ready to jump right in here and do the next lesson on quadratics we're going to talk about today. And that next thing we're going to talk about today is the following. We want to talk about how we're going to complete the square. Completing the square. Okay, so you're thinking to yourself, completing the square, that sounds easy enough. I mean, a square is just a four-sided polygon, right? And it's got all four sides are congruent. Yeah, great, Mr. Snyder, that sounds easy enough to me. But that's not what we're talking about when we're talking about completing the square. We're talking about algebraically, what does that mean? So everyone in here should know the following. By now, we should all know, if I were to give you something like, oh, I don't know, maybe x plus 2, the quantity squared, and I asked you to expand this, that we would get square the first term, x squared, multiply these and double it, and we would square the last term and we'd get this. That this is referred to as a perfect square trinomial. That is called a perfect square trinomial. Okay? Well, what we want to be able to do today is we want to take quadratics that we have that may not be factorable and somehow make them factorable. And you're thinking, whoa, what? Make them factorable? If you can't factor them, how can you change them to make them able to be factored? Well, that's our goal today. So we're going to try to go ahead and do this thing called completing the square today. Now, completing the square also means this. Completing the square means that the following will happen. We will be able to write a quadratic in vertex form. And if you remember what vertex form is, it's y equals a times x minus h, the quantity squared, plus k. We're going to be able to get all of our quadratics in this form if we want. And remember, the beauty of this form is that it tells us where the vertex is, and it also gives us the max or the min. The value of k is a maximum if it's positive up here. Or this is a maximum if a is negative, and this is a minimum if a is positive. So we get that information from this form called vertex form. Okay. So here we go. Let's go ahead. I'm going to erase this, and we're going to keep going here. And let's talk about what our goal really is here. Okay. So, let's say I were to do the following, and I wanted to solve the following equation. I want to solve this. Okay, y equals, how about 2 times the quantity of x minus 3, the quantity squared, oh, I don't know, minus 20. I want to solve this. Now remember, solving it means finding the zeros. So I want to find the zeros of this function. That's easy enough. So I'm going to take this and set it equal to 0. So I would add 20. And I get 2 times x minus 3, the quantity squared, equals 20. And then I could divide by 2. That pen's not happy. And I would get x minus 3, the quantity squared, equals 10. And I would take the square root, and I would get x minus 3 equals positive negative radical 10. And I would add 3, and my final answer would be x equals 3 plus or minus radical 10. Okay? We did that. We solved quadratics that were out of this vertex form, and we did it by using the square root property. We would get this binomial squared by itself. That was our goal. We would get this binomial squared, this guy, right here. We wanted to isolate it like this down here, and then we would take the square root of both sides, and we were almost done. So if I'm able to put a quadratic in this form, then I could solve using this technique. All right, so here we go. let's go with this. I'm going to erase that. I'm going to put a new problem up here I want to solve. I'm going to put a new one up here. So here we go. Let's say I wanted you to solve the following. Okay. I want to solve, how we got here? How about x squared minus 4x plus 11 equals 0. Actually, let's make this minus 11 equals 0. Okay. Now you look at this, and I'm hoping you're saying, well, my choices would be, I could factor this. This doesn't factor. 11 is a prime, so its only factors are 11 and 1, and there's no way to take 11 and 1 and get a sum or difference of 4. So this is a prime. It's not factorable at all. So how will I deal with this? Well, watch what I'm going to do. I'm just going to have you watch. Remember, when I'm working with an equation, as long as I'm doing the same thing to both sides, that means if I'm actually changing the value of a side, not its appearance, but its value, I have to change the other side by the exact same value. So that's what I have to remember. So let's go ahead and do this. So I'm going to take this, and I'm going to start by adding 11 to both sides. And I'm going to get x squared minus 4x equals 11. Okay, now, so all I did was put the constant term on the other side. Now remember, now as long as I'm doing the same thing to both sides, I'm okay. On this left-hand side, I'm going to add something to it. X squared minus 4x. Now here's what I'm going to do. I'm going to add a number, and the number I'm going to add is I'm going to take half of this number, okay? So I'm divide it by 2, and then I'm going to square it. That's what I'm going to do on the left-hand side. Now, of course, that means I have to do the exact same thing on the right-hand side. So let's think what that really means. That means I'm going to get x squared minus 4x. This is going to give me negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So I'm adding 4 on the left, which means I'm also adding 4 on the right. Completely okay with what I've just done. Now on the left, I'm not going to add, subtract. I'm not going to change its value. I'm just going to change its form, its appearance. I'm just going to rewrite it in a different form. This is now a perfect square trinomial, and I can factor this. So I'm literally going to factor this right here. So this becomes x minus 2, the quantity squared, equals 15. Now I can actually solve this. I can solve this because I can take the square root of both sides. And I get x minus 2 equals positive negative radical 15. Add 2. And I get x equals 2 plus or minus radical 15. So I was able to go ahead and do this problem and get an answer even though this was not factorable. And the only reason I could do that is I was able to rewrite this and change it. Okay? That's what I did. I rewrote it and changed it. So exactly what just happened? Well, what I did here was this is called completing the square. It means taking this right here and adding something to it to make it a perfect square trinomial. I completed this to make it a perfect square trinomial. That is our goal today. All right? That is our goal today. So, here we go. Let's do another one of these. All right. So let's say I gave us this. Negative 3 times x minus 1, the quantity squared. Actually, I don't want that. Whoop. Back up. I want to give you x squared plus 8x minus 2 equals 0. I want to solve this. Again, this cannot be factored. It can't be. There are no two binomials that I know of, x plus a, x minus a, x plus a, x plus b, x minus p, x minus q, whatever you want to call those factors. This is not factorable, okay? So watch. First step, step 1, move the constant term to the other side. So that's my first step, is to move that constant term to the other side. So I'm now going to have x squared plus 8x equals 2. All right? Next step is to actually complete the square, is to add something new to the left-hand side. I want to add something new to this left-hand side. So it's x squared plus 8x plus. Now the number that goes in here is the b value divided by 2 squared. It's the b value divided by 2 squared. And if I add it on the left, I have to add that new number on the right as well. Okay, so on the left, what I really have now is x squared plus 8x plus 8 divided by 2 is 4. 4 squared is 16. So I really added 16 on the left, which means I have to add 16 on the right. This is now factorable. It's a perfect square trinomial. Square root of x squared, x. Square root of 16, 4. The sign of the middle term, boom. Equals 2 plus 16, 18. Now I finish it. Square root x plus 4 equals positive, negative. I am going to simplify this. This is going to be 3 radical 2. Subtract 4. And it looks like x equals negative 4 plus or minus 3 radical 2. Look at that. Okay? This technique is known as completing the square. All right? Completing the square. Okay, so I don't want to take a look at that. It's a beautiful thing. It's a beautiful thing. Love it. Okay? So this allows me to solve it. This is allowing me to solve this. Sometimes that's what you want to do. Sometimes we want to solve. What if instead of solving it, I wanted to do the following? Okay, I'm going to put this over here. So I want to write x squared plus 6x minus, minus 9. Okay. I want to write x squared plus 6x minus 9, y equals that, in vertex form. That's what I want to do. I want to write this standard form in vertex form, so I'll know if it's, I want to be able to find the max or the min. So that's what our goal is right now, okay? We're going to try to go ahead and take this and put it in vertex form. And of course, vertex form is y equals a times x minus 8, the quantity squared plus k. That's what I want to get to right there, vertex form. Okay, great. Here we go. So I'm going to rewrite this over here. Y equals x squared plus 6x minus 9. Step 1, I'm going to do it this way to start. Step 1, move the constant term to the other side. So I get y plus 9 equals x squared plus 6x. Okay, now I want to make this a perfect square trinomial on the right. So what would I have to do? I would have to make this x squared plus 6x plus half of 6 is 3. 3 squared is 9. Again, this number right here, that number is 6 divided by 2 squared. That's where this 9 came from. Now, if I add 9 on the right, I have to add 9 on the left. So I have to do the same thing to both sides. So this is going to become y plus 9 plus 9. So now I get y plus 18 equals This now factors. Factor it. X, square root of 9, 3, middle term's positive, plus, boom, there it is. Last step, move the constant term back over. And I'm at y equals x plus 3, quantity squared, minus 18. So now I know that this quadratic, since the leading coefficient A is positive, I know that this graph is going to open like this, and I know this vertex is at -3, -18. So this parabola has a minimum of -18 on it. So we can use this completing the square two ways: to solve, okay, to find the solutions, the zeros, the x-intercepts, the roots of the equation, the function, or we can use it to rewrite it in vertex form so we can know what the maximum or minimum is and where that is occurring at. So this is another way we can use this. We're going to do another one like this, okay? We're going to do another one where we write it in vertex form. So I'm going to get out of here. And I'm just going to come over here and I'm going to erase this one and we're going to just put a new problem in here. Okay, so I'm going to make this one look a little bit different. This one is f of x equals 2x squared. How about plus 16x plus 1. There it is. This is the one I want to work with. I want to take this and get it into vertex form. Okay? So, the first step is I'm going to rewrite my problem here so that I actually have it so I can work on it. So let's put it over here. So I've got f of x equals 2x squared plus 16x plus 1. All right. So step number 1, move the constant term to the other side. So I get f of x minus 1 equals 2x squared plus 16x. Okay. Now, this one's different than the last one. On all the previous problems, this value here was the number 1. Here it's not. Here it's the number 2. What I have to do at this point in time is I have to factor out the GCF of just the coefficient. Do not pull out the greatest common factor. I want to pull out the greatest. I have to pull out this factor right here. The value of A must come out in front. So what I get is I get f of x minus 1 equals. So I'm going to factor a 2 out. So I'm going to be left with x squared plus 16 divided by 2 is 8. Boom. There it is. So I had to factor out this number right here, whatever it was. If this was a 3, I would have had to pull out a 3. If that would have been a 6, I would have had to factor out a 6. So I had to factor this number out right here, whatever it was. Notice, I did not pull out the greatest common factor. I did not pull out the x's at all. Right here now is where I need to complete my square. So pay close attention. Okay, here we go. 2 parentheses x squared plus 8x. Now, the number that goes here is half of 8 is 4. 4 squared is 16. Okay? So now on the other side, I have to keep my equation balanced. It's f of x minus 1 plus, here's the deal. Right here, I am not going to add 16. And you're like, well, Mr. Snyder, that's what you should do. If you don't do that, you're going to get this problem wrong. Well, no, I'm not. I'm not going to get it wrong because here's what I know. On the right-hand side, what I really changed the right-hand side by was I added 32 to the right-hand side. 2 times 16 is 32. I have increased the right-hand side by 32. So I have to increase the left-hand side by 32. Again, since this was not a 1, I had to take this number outside and distribute it to this number I added in here. 2 times 16 is 32. So I've really added a total of 32 on the right-hand side. That means that I have to add 32 on the left-hand side. Now at this point in time, I can finish up this problem. Now I can go ahead, f of x, oops, not that, f of x, boop, 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 boop. This is going to give me plus 31 equals 2 times x plus, remember, square root squared, subtract 31, and I get f of x equals 2 times x plus 4, the quantity squared, minus 31. Boom. Did it. So now it's in vertex form. Vertex is at -4, -31. That's a positive. Since it's going to open like that, that is a minimum value. So that's the minimum value of this quadratic. Okay. So we're looking at, there's two ways we're using this idea of completing the square. Okay, two ways of using this. All right, so I'm going to do one more, and then I'm going to kind of give you a general way of looking at this every time. Let's do one more. So here we go. Let's write f of x equals -3x squared plus 12x minus 7. All right? So this is the problem. I want to put it in vertex form. Okay, so we're just going to go through this. So it's f of x equals -3x squared plus 12x minus 7. So my first step, move the constant to the other side. So I get f of x plus 7 equals -3x squared plus 12x. Step number 2, I have to divide this. I have to factor out the -3. So it's f of x plus 7 equals -3 times x squared. Now look, since I'm factoring out a -3, this sign's going to change. So this is now going to become minus 4x. And I can check to make sure. If I redistribute, I'd get -3x squared plus 12x. So there it is. Now I've got it here. Now I complete the square. Okay, so it's going to be -3 times x squared minus 4x plus half of -4 is -2. -2 squared is 4. On the left, what's going to happen? Now remember, this is where you have to be careful. On the right, I've changed it by -12. -3. I've changed the right-hand side by a value of -12. So I have to do that on the left-hand side as well. Those numbers must be the same. Now I should be able to go ahead and factor this. F of x, here you're going to get -5 equals -3 times x. This is going to be -2, the quantity squared. Add 5 to both sides, and I get f of x equals -3 times x minus 2, the quantity squared, plus 5. Boom. There it is. So now I've got it in vertex form. What do I know? This time, I notice that this thing has a -3 in the front. So since it's negative, it's going to go like this. It's going to open down. That means it has a maximum. That maximum is going to occur at 2, 5. So it has a max value of 5 when x is equal to 2. Our goal today, use the idea of completing the square to either solve a quadratic or to get a quadratic into vertex form in order to find the maximum or the minimum. So let's see what do we do every time, okay? What was the idea of how we did this? Well, what we really did is this. Right here, it's f of x equals ax squared plus bx plus c. That's what it is right there, okay? In order to complete the square on this thing, okay, like this, what we literally did was we started by moving the constant to the left-hand side. There it is. The next thing we did was we factored out this a value right here. Boom. So you get f of x minus c equals a times x squared. Remember that? Plus b over a x. Okay? Because if I redistribute, here's ax squared. Here I'd get plus bx. Now I want to complete the square. I want to complete the square on the right-hand side. So let's go ahead and do that. So now I'm going to get f of x minus c equals a times x squared plus b over ax plus, remember what we do, we have to take half of this and square it. That is going to be b squared over 4a squared. It's half of this. Remember, this right here is b over a, okay, right here, divided by 2 squared. That is b over a. Dividing by 2 is the same as multiplying by 1/2 squared. So that is b over 2a squared. There it is. So now I have this right here. Now, what happens? I have to do this on the left-hand side as well. On the left-hand side, at this point in time, I have f of x minus c. Okay, I need to see what I've changed the right-hand side by. So this is where you have to go like this and distribute it. Now on the right hand, if I do a times this, what I end up getting here is b squared. This is going to give me right here, I'm going to just draw it, b squared over 4a. So I've added b squared over 4a to the right. I also have to add it to the left. There it is. Beautiful. Okay? So now I'm here. All right? Now I'm here. So this is what I have done. And then here I'd have to combine these and these as well. I could factor this if I want. I could go ahead and keep going with this. Okay? So what would happen here if I did this? Well, let's see. This would become f of x minus, this would become what? I'd have to change this to 4ac. Is that right? Yeah, 4ac over 4a. Boom, boom. Plus b squared over 4a equals a times square root of this, x. The square root of this is b over 2a. This becomes a plus squared. Look at that. So now I have f of x equals, what do I get over here? I get f of x. This is going to give me what? b squared minus 4ac plus b squared minus 4ac all over 4a. Okay, all over 4a. And that's going to be equal to this now. And then I'd have to move this to the other side as well. Now, that just is so much to look at here. So it looks like f of x is equal to a times x plus b over 2a, the quantity squared. It's running out of ink. Quantity squared. And then this is going to be minus b squared plus 4ac all over 4a. Oh my goodness, that is absolute insanity. Wow. Wow, wow, wow. Cool. Okay. Now, I don't expect you to do this. I don't expect you to do this algebraic stuff here. Okay? So this is where we are on this right now. This is where we are right now on this. Okay. Yeah, I like that. So tonight, you're going to try to do some completing the squares by using these different methods, either on the solving or putting into vertex form, using my examples as what you should do. Okay? You also can use your book as a set of examples of what you can do. So having said that, hey, we'll come back. We'll talk about this together. I'll do extra problems if you want me to. And I just appreciate that you've stuck with me. And hey, have a great one.